Hi, can you hear me? No? Oh. It's really weird because I can't hear my own voice amplified, but of course you can all hear me very clearly. So, I'm really happy to be here in London today. As you can hear from the accent, I'm Australian, came over from Berlin for this talk, so I'm super happy to be here. So I'm the data science developer advocate at JetBrains. We're a company that specializes in making tools that make the life of data scientists and developers easier. In terms of why I decided to give this talk, so my background is I have a PhD in health sciences, typical data scientist story. And then after that, I transitioned into industry, and I've been working in data teams for around 7 years now. So I've seen a lot of different environments and a lot of different ways in which people work with data scientists, with data engineers, and with data analysts. So you might have noticed I'm not the only name up there on that title slide. So initially, I actually wanted to present this talk with my colleague, Pasha Finkelstein. He is the big data developer advocate at JetBrains. However, unfortunately, he couldn't be here today, but we put this talk together, and I've also combined into this talk his knowledge about working with data from the data engineering side. So this talk combines over a decade of shared knowledge, shared opinions, and I'm hoping I can give you sort of a perspective on how complex data teams can be, the different roles and responsibilities and skills that are needed to make a successful data team, and my own opinions from my experience about how to get the most out of those roles that you hire for. So, to get started, I'd like you to think of the first role that pops into your mind when you think of who works with data. So, I think for many people nowadays, this would be a data scientist. And this myth of what data scientists can do with data has really just grown over the years that I've worked in this career. And I feel that many companies imagine that if they can just hire one of these, big brain PhDs, they're going to be making millions with AI products. But unfortunately for these companies and for the ego of people like myself, this is not really the case. Data scientists are not the only members of data teams, and in many cases, we may not actually be required, depending on what your company wants to do. So in reality, unless you have a very small or early stage startup, no one person should or can do everything that falls under the data domain. So I'm going to describe how these responsibilities would be typically distributed in a mature data team. So to ground this talk a little, we're going to be using an example of a fairly typical problem that a data team might need to solve. So let's imagine that we work at a large fashion e-commerce called, Trasos, and we want the data team to build a recommender system. So what this recommender system is going to suggest items that are similar to ones that they've bought before or looked at. So the reason that we want this recommender system is we want to retain customers that we already have, and we also want to make it cheaper. We also want to make it cheaper to get new customers. And we're hoping that this, of course, leads to more sales and more revenue. So I hope you can see that we're not dealing with some sort of really abstract data problem. We're dealing with something that impacts the all-important bottom line of the business. So concretely, what do we want this recommender system to do? We want it to increase the rate of converting non-customers, which is going to make those acquisition campaigns cheaper. In addition, we want to increase engagement among our existing customers. We also have a number of technical constraints that are going to affect our recommender project. Our data are massive, and it's made up of a bunch of simple events, things like clicks and scrolls, and these need to be processed and converted into something that we can actually use in our recommender system. In addition, our backend system is written in Scala, but our data scientists work in Python, and this is a pretty typical setup. I've seen this a number of times. So any model that your data science team is going to create needs to be able to work with that Scala backend. So to understand what the business needs and what our technical limitations, now that we understand what our business needs and technical limitations are, let's spell out exactly what we're going to need to do in order to deliver this recommender product. So the first thing that we need to do is concretely understand the business question. Does it even make sense to build a recommender system? How are we going to measure it? And is it actually going to achieve our business goals? And how are we going to compare this with what we're already doing, say manually advertising in order to increase acquisition? So once we've worked this out, we need to define what the required data is in order to fulfill this project. Following that, we need to prepare the data. Data are not necessarily in a form that's going to be best for this recommender project. We then get to the fun part for me, which is researching models. So I think a lot of people think of this as the main component when building some sort of data science project. But as you can see, it's just a small part of the entire pipeline. Once we've decided on a model that meets our criteria, we can then productionize it. And that involves things like preparing data pipelines, preparing how we're going to serve the model, things like that. And then finally, we need to build monitoring. And this is going to be the difference between prototyping and actually having something that is going to be, able to be working stably, that we can debug, that we can check for issues. Okay, so this is a really big list of work, and I think you can see that it requires many different skills. So to me, we can broadly divide these skills up into 3 different areas. So the first of these is domain knowledge. This is having a deep understanding of what the business actually does and what kind of things that would help it improve or succeed. So analysts are our deep domain specialists. The second area is science. This is using research skills in conjunction with data in order to answer vague questions or maybe build data products. And of course, data scientists, we spend most of our time in that science domain, but we also have analysts that need some sort of research skills in order to answer business questions. And the final area is engineering. So data engineering, which is the specific branch that we're going to be talking about in this talk, is concerned with organizing, processing, and storing data. And this gets more and more complicated the bigger the data gets. So we have a few different specializations. We have data engineers who have deep domain knowledge, and these are known as analytics engineers. We also have people who have a command of both data science and data engineering, and these are called ML engineers. And then finally, at the intersection of all these, we have our data ninja rockstar. And this is a person that we're asking to have a deep understanding of the business needs, their current operations, excellent research skills, and high-level engineering skills to get everything into production. So I think you can sort of see why these people are such unicorns when it comes to hiring, and how it would be very difficult to hire someone who can do that, especially as you have a complex data stack and complex business needs. So for example, at my last job, we had a number of ML engineers that worked with us, true ML engineers. One of them left and we had to hire to replace him. We hadn't hired to replace him by the time I left, and that was over a year later. So you can imagine that if we were trying to hire someone who has also very deep business knowledge on top of that, it's going to be a really hard sell. So you can probably guess from the title of the talk and what I've just said, I'm going to caution against trying to hire this all-in-one kind of person, and instead see how we can divide up the roles and responsibilities in order to build the strongest data team for your needs. So the first role that we're going to talk about are my people, the data scientists, or as I'm going to call them, the research folk. So what do data scientists do? It's a question I get a lot. I can sort of say a cheeky answer is it's in our name. We work with data and science. So we're concerned with doing research with your company's data. Now, this is not a very helpful answer. What do I actually mean by this? Why would you hire a data scientist? You might hire a data scientist to automate processes within your company that are being done manually. So this might be things like rating the quality of leads for a call center, or finding terms that might improve your search engine, or, as we're doing here, improving your manual acquisition efforts by building a recommender. You might also use your data scientists in order to build a data product. You might add that to your existing product in order to increase the value of what you're doing, or you might even sell that product separately. So for example, at my previous job, I was working in an ad company. Basically, those mobile ads that you see on your phone, we were concerned with buying and selling those. So one of my jobs was basically taking that information and profiling people to see whether, you could work out their interests. That helps improve the value of those ads because you can target people who will likely be interested in your product. So what are our core skills? Of course, mathematics, everyone knows this. We use statistics in order to resolve the uncertainty around the things that we're finding. Is it likely that these two things are actually different or related? We also, of course, use machine or deep learning models in order to make predictions about the future. We also do some programming, but our programming skills are not the same as hardcore engineers. They tend to mostly be for prototyping. And we mostly use languages such as R, which is a specialist scientific programming language if you haven't heard of it, or we use scientific packages within Python. And that means you don't really need to be hiring data scientists who know languages like Rust or C or JVM languages. Really, the specializations are in languages that suit the job that they need to do. And then finally, of course, everyone knows data scientists love to do graphs. Data visualization is one of our skills as well. So let's go back to our recommender product. What responsibilities are our data scientists going to have? So at the beginning, they're going to be responsible for helping to translate that business question and seeing whether it even makes sense to solve it from a data science perspective. Like I said, we're going to be working out, does a recommender even make sense here? We're also going to be looking at those goals that the company wants to meet. We need to see, how much uplift in acquisition and retention do you want? Do we think that this is feasible with the model that you want us to build? And we also need to provide an estimate of the likely complexity of the project. And then we need to help the business work out, is this actually going to cost you less than actually doing this manually? Machine learning problems are not a silver bullet. They have a cost, and maybe it's actually cheaper to do it manually. We then start by digging through all of our available data, and we put together a wish list of everything we think could be useful for our model. And then after that, depending on how hard it is to access that data, we might go and retrieve that data ourselves, typically maybe through SQL or Spark or tools like that, or we might ask our data engineering team to prepare us a sample. Now to the fun part, the model creation. So what we first do is we start preparing the data for a form that's going to be useful for modeling. And this is a process known as feature engineering. We'll then iterate through different models and check their performance. And we're keeping in mind at all times the business goals. We don't just create models that are fun. We don't create models for 99% accuracy if that doesn't work. We keep in mind those business goals. And of course, we also keep in mind the technical constraints. We're constantly communicating with the data engineering team or the deployment team to work out, will this solution actually work? We then have an interesting point where we hand over the model for productionization. What this means depends on your individual data science and data engineering teams, and I'm going to be coming into a deep dive about this at the end of the talk. And then finally, let's say we've finally gotten to the point where everyone agrees what an acceptable model is, we productionized it, we now need to build monitoring. The monitoring that the data scientist is concerned with are around the model metrics, how well the model is performing in terms of those sort of scientific metrics around how a model performs. So the next role I'm going to talk about is the business intelligence analysts, or as I'm calling them, the data communication folk. So in contrast to the data science team, BI analysts are responsible for understanding the business as usual. They need to know what information business people need to know about how the company functions and how to extract this story from the data. So much of this work, of course, involves communicating these findings to business stakeholders. So they either create dashboards or they might do ad hoc reports. And what this means is that they need extremely good data visualization and communication skills, and they also need to know how to manipulate the data to get it into a form that will be most suitable for presentation. They also need to do, as I said, some data exploration and analysis. So they're typically very good at doing this using tools such as SQL or SQL, and they'll usually use tools like Power BI or Tableau in order to present their findings. So let's go back to our recommender product, and what responsibilities will our BI analyst have on that project? Well, firstly, they're also going to be involved at the beginning. They need to talk to business and data science, and again, help work out whether those acquisition and retention goals are actually feasible. And interestingly as well, they're going to help us answer the most important question: what's going to be the financial impact of this project? It's what we care about in the end. The BI analyst also needs to design metrics that are going to be used to measure that business impact. So at the beginning, they may pull a sample of data and just mess around to see what metrics are going to reflect that uplift most accurately. And again, they may get that data themselves, depending on how available it is, or ask the data engineering team to do so. So once our recommender MVP is ready for production, our BI analyst is going to come back and work out what data pipelines need to be built in order to produce those tables that they need for reporting. So those are going to need to be ongoing reporting. So there's going to need to be probably specialist data transformations and tables that are produced in order to do that. And then following that, they're going to do their monitoring. So these monitorings are usually dashboards, as I said, using tools such as Power BI or Tableau, and they're going to be responsible for monitoring how well the model is improving those acquisition, retention, and financial goals. They're primarily responsible for monitoring if things go wrong in this aspect. So they need to work out with business whether that model's not performing as well as we thought it would. They also need to alert data science and data engineering if something seems to have gone drastically different and drastically wrong. And in order to do that measurement accurately, they may also design experiments. So they might ask, only apply this model to a subset of our customers in order to have a baseline to accurately compare that uplift to. And then finally, we have the third role on the data team, our data engineers, or as we're calling them, the big data folk. So the main job of a data engineer is to deal with the data lifecycle. So what do I mean by this? In contrast to data scientists, who usually deal with static extracts of data, data engineers work with living data that's coming into your business in a constant stream. So the four components of the data lifecycle are the consumption, processing and storage of this data, and then making that data available to customers in a sensible way. By customers, I mean other people in the business, data scientists, BI analysts, other people who might need access to it. So there are many, many tools for doing this. Most data nowadays is stored, of course, in the cloud. So it might be stored in things like S3 buckets or in database servers like Google's BigQuery. And key things that data engineers need to worry about is things like the cost of storing and processing this data. In my last job, we were dealing with data at the rate of something like 2 million events per second. And our data engineers had to work out how to actually store that in a sensible way. Do we store all of it? Do we sample it? How much is this going to cost? And this is really going to depend on your business. It's so idiosyncratic. So in order to do all of this, unsurprisingly, the data engineer needs very strong engineering skills. So the languages that they're going to be proficient in are very idiosyncratic. It sort of ranges a lot. Let's say in our case, obviously we're working with a Scala backend, but we have customers, our data scientists who are working in Python. So we're probably going to have data engineers that are proficient in both. The data engineer needs to create stable, well-tested data pipelines. And in order to do that, they need to create maintainable code. And this code needs to produce deterministic results. This is not an easy thing to do, and it does require careful and thoughtful engineering to do it. And you can see that the goal and the scope of their code is very different from the scope of my code, which is usually terrible and should not go anywhere near production. So, in order to make sure that everything's working properly, they need to build monitoring pipelines for their data. So they're going to build monitoring for this specific project, but monitoring is business as usual for them. They're always checking how the data is going. And depending on how mission critical the data might be, they might be on PagerDuty. So that might be part of their role. As data tends to be one of the core parts of any business, as I said, they work with other teams. And it's common to basically see other teams as their customers. And then finally, depending on the team, they may be responsible for deploying ML models into production, but we'll talk about this in the rest of the talk. So let's look at the role that data engineering team is going to play on a recommender project. So they can help us understand from the outset whether the data is going to be sufficient for our project. They might be able to highlight any issues that we don't know about. So maybe we don't actually have coverage of all of the customers that we want to reach. We might have a lot of missing events. They're going to be able to flag those issues up front because they know the data intimately. They can also point our data science and BI analysts in the right direction for tracking down their data shortlists. And as I said, they may be responsible for extracting those samples that those teams need. Another kind of example of us being customers of them. As we've already discussed, the data engineer will help the data scientist decide what's going to be an appropriate implementation of their model, from a technical perspective, of course. And then once that model is completed, this is where the data engineer has to do a lot of heavy lifting. They're going to be responsible for building the data pipelines that everyone needs to use. So both the data science pipelines that are feeding into the model, the pipelines to basically build those tables that the BI analysts are going to use for reporting, and all of the monitoring that everyone else is going to be using. So the data monitoring and also the model monitoring. And they may potentially be responsible, as I said, for implementing those models. And then finally, they need to build their own monitoring. And that's just to check whether those new pipelines are performing as expected. So I've made the distinctions between the teams sound really neat, but I think we all know from experience this is not the case. So what I want to talk about is a couple of cases where the overlap is a bit of a gray area. And the first one that I'm going to talk about is, what does it mean to hand off a model from a data science team to a data engineering team? So I've seen everything. I've seen the approach from data scientists, you just focus on your Jupyter notebooks, we just chuck them over the fence and the data engineering team can deal with that. I've also been on PagerDuty for an app that was in production. I didn't like either of those approaches, and I will tell you, I don't think either of them are the best. I think they're the two extremes. Where that kind of handover is going to be really depends on the skills and interests of your data scientists and your data engineers. You may have data scientists who do have substantial data engineering knowledge or engineering knowledge. They're more likely to be ML engineers, but that may be the case. So in that case, maybe they're going to be helping more in a hands-on way with production. You may also have data engineers who have significant interest and experience in modeling, in which case they may be sitting with the data scientists and actively involved in that model deployment process. It also depends on basically what kind of solution you've come up with. So in our case, we might be able to come up with a solution that can be implemented in pure Scala. There are certain, statistical distributions that might be an appropriate solution. We might be able to use something like approximate nearest neighbors. Is a bit technical, but these are solutions that could be coded up in pure Scala, in which case obviously your data engineers are going to be responsible for that code, and they can be responsible for that code. We might also have something that is locked into Python, in which case we might need to use some sort of serving solution. Maybe your data scientists then are responsible for the code. The most important thing though is you having communication up front, and you have a pre-arranged definition of done, of what that model handover looks like, so no one is surprised at the end when suddenly your data scientist is saying 3 months of work ahead for you data engineers, and actually business wants it next week. So the next overlap is when things go wrong. So one of the main reasons that I've really emphasized having a division of monitoring is to make sure that the right people are keeping an eye on things going wrong in a timely fashion. So obviously, if something's going wrong with the model, the most appropriate person to understand that is the data scientist. Something's going wrong with the data, the most appropriate person is the data engineer. But sometimes it's not so simple. Sometimes things go wrong and it's really not clear. I know it sounds a little trite, but obviously in that case, it's a team effort. And you really should have this attitude that when things are in production, it's not just the engineer's problem. Everyone needs to be responsible for pitching in, helping to understand, and having also a prearranged definition of what's urgent and what's not. So you don't necessarily have, people getting woken up at 3 a.m. for something that could have waited until 9 a.m. So let's summarize what we've covered today. Of course, I have a platypus, I'm Australian, I need to do my homage to home. So data is complex. There are a lot of different responsibilities, and we need to sort of distribute those. They can be really broad, and that means that it's really difficult to hire someone who can cover everything. And that is particularly the case as the size and complexity of the business grows. We can split this between 3 domains: engineering, science, and domain knowledge. And these are generally tied to specific roles. And depending on the needs of your business, you should hire from these roles accordingly. So thank you so much for listening. Here are my details. You can see my Twitter handle, you can see Pasha's Twitter handle, and I also run a blog. So if you're interested in extremely nerdy data science content, I have like 7 years of it. And yeah, I'd love to hear any feedback. Thank you. I think we may have time for a couple of questions if you're interested. I have been instructed to get you to raise your hand if you want to ask one, and I'm just going to pop these on. Oh, I think we have one question here.
Cheers.
I'll be at the JetBrains booth, by the way, so come and find me, yeah.
Can you hear me? Yeah.
Yes, I can.
What's your advice about building a team around someone who is a ninja?
I know, this is a really tricky situation, right? So your business grows and you've got that one person who's basically your blocker. I would say if they have the interest, try and promote them to become the person who trains up everyone else. If not, try and get them to understand what area they like working in most, because they're probably going to have an inclination more towards engineering or more towards data science or more towards analysis. So yeah, it's also a person problem, right? But I think putting them in more leadership roles, even if it's a technical leadership, not even, like technical leadership roles are very important too. So if they've got the chops to go into leadership positions, that's probably the best solution for everyone. They pass on the knowledge, they train up everyone, and then they don't feel slighted or demoted. Yeah, as I said, oh yeah, hey.
Hello, can you hear me?
Yeah.
So I have a question when like you need to make like a swift decision or something that's like very like the topic or problem that's like very interconnected with all those 3 topics. And you do, in that case, it sounds like it's the best way if you can have that super ninja person who basically have all the knowledge, who can make the best decision very swiftly, because obviously if all the 3 domain people have different decisions, then like it's very hard to come to a consensus. So in that case, what's going to be like the best solutions?
Yeah. So I can actually give you an example of this. So I was part of a squad, however you want to define that. We were developing an MVP that needed to get out super quick, like I would say within 3 months. And we actually, because we had good relationships with each other, because this is the important thing for consensus, right? We trusted each other. We just met super regularly and were able to therefore kind of act already as a team. So I know it seems kind of tempting to just have one person who can guide you as a captain through the storm. I would say it's really dangerous though, because that person has one particular perspective. I don't think that their perspective necessarily gets more nuanced or broad because they're working along, like across a lot of different domains. I think they actually get very fixed into one particular way of doing things. And I will also say, I have deliberately chosen jobs where I've had to work with engineers because I am not an engineer, and that has been super valuable for improving my thinking. So I don't think I really answered your question, but I think I'm maybe saying I still don't think it's a good idea. I think you just need to foster an environment where you have mutual respect and you've got technical leads across the 3 who will at least see each other's perspective. Oh, we're done? Cool. As I said, I'm at JetBrains. I'll be at the booth soon. If you want to chat more, please come and see me. Thank you so much. You're a wonderful audience. Thanks.